Now we are moving on to the next topic, which is law of conservation of energy. So as the name suggests, what would be this law? The name suggests that the conservation of energy, that is the energy remains conserved. So as per the definition, total energy of a system always remains conserved. So what if a body is at rest and after that it starts moving? So how can we put this law of conservation of energy into that body? Suppose this body is initially at rest and after some time it is moving. So how can we apply the law of conservation of energy? This is applicable in the case that the body is at rest at this point. So right now the body is possessing the energy in terms of its potential energy because it is due to virtue of its position. Now when the body starts falling, it has gained the velocity and it hits the ground with some final achieved velocity. So in that case the body has maximum kinetic energy, but at bottommost point the potential energy is 0. So what exactly happened? The potential energy got converted into kinetic energy. So whether or not, if a body is moving or not, if a body is in motion or not, one form of energy always changes into another form of energy, and that is why this law of conservation of energy is a universal law. It is applicable everywhere at every point. For example, all these machineries around are also working on the law of conservation of energy. For example, if you are sitting in a room where your fan is currently working, so fan is giving you proper breeze, that is why you are not feeling hot. So on what principle fan is working? Fan is a device which is converting mechanical energy to electrical or electrical to mechanical. Yes, electrical to mechanical, because current is coming in the whole system and after that it is moving. So current, that is electrical energy, is getting converted into mechanical energy. In case of windmills, wind energy gets converted into electrical energy. In case of light bulbs, electrical to light. In case of loudspeakers, electrical energy into sound energy. In case of microphone, sound energy into electrical energy. So these energy conversions are always true and they are all governed by this universal law, which is the law of conservation of energy, which states that total energy always remains conserved. So we understood the fact, alright, if this law is stated, the law must be true. Okay, we accepted that it is true. But what if they ask us to derive it mathematically? Okay, let's prove law of conservation of energy, that total energy remains conserved. That means total energy is always same. For that, I am considering a ball which is at a height h from the ground and it is allowed to fall freely. Okay. So what we are going to do, we are going to find the value of its total energy at position 1 and at position 2, and let's see if they are equal or not. Then first of all, total energy at position 1, I should write it in more better way because I want to be very expressive in terms of what I am writing. So total energy at 1 would be potential energy at this position plus kinetic energy at this position. So here I don't want to mention it. Now potential energy is mgh, whereas the kinetic energy is what? Nothing, because the body is at rest or it is falling freely, a body from rest falling freely. So initially the body is starting its journey from rest, u equal to 0. So kinetic energy is 0. So total energy comes out to be mgh, which is at position number 1. Alright. Let's talk about position number 2, which is the bottommost point. Total energy at second position would be potential energy at second position plus kinetic energy at second position. Now, what is potential energy at the base? There is no height absolutely, that means the potential energy is going to be 0 this time, while we'll have kinetic energy as half mv square. I don't have to mention that I have considered mass of the body to be m. Right? Acceleration due to gravity is g. These are the normal terms which we already have been using. Now we want to write the value of v. For that I am going to use an equation which is v square minus u square is equal to 2as. So v square minus u square, instead of u square I have written 0 because there was no initial velocity, body started from rest, is equal to 2as. A is acceleration due to gravity here, which is g, and s is the height, so that is 2gh. So instead of v square, so this gives us v square is equal to 2gh. put this value of V square here, what will you get? This equation will become half into m into 2gh. So 2 cancels out, you are left with mgh only. So that means total energy at position 2 is also mg and h. So this proves our law that total energy always remains conserved. Let it be position 1 or 2. Alright, this was quite simple. What if we have to find this position or total energy thing somewhere in the between? Let's say it has already covered this x distance now. So remaining distance which still has to be covered is h minus x. Okay, because total height was h. So now let's find out the total energy at this new position, which is our third position. If this comes true, that means the law of conservation of energy is validated. Alright. Now we are finding out total energy at position number 3, which is potential energy plus kinetic energy. Now potential energy at this point is something, because the body is already at some distance from the ground, so the distance is h minus x. So here I'll get mg, the distance is h minus x. This is the height, or this is the potential energy of the body. Now kinetic energy is half m v square, but I have already used the v here, so I'll be using v dash square. Okay, so this is our v dash square. Now this is, before moving on further, let's find the value of v dash the way we found it here. So v dash square minus initial velocity u square, which is 0, is equal to 2as. A is acceleration due to gravity, whereas s is the distance covered, and the distance covered from position 1 to 3 is what? X. So 2gx is v dash square. This is what we got. So now I am writing the value of v dash square here in this equation, half mv square. I'll get half m v dash square is 2gx. Oh, I wrote it as it was x. So this is mgx. So this term is basically mg x, not h. Okay. Now let's open the brackets here. I'll get mgh minus mgx plus this term which was mgx. So I'll cancel out mgx and I'm left with mgh again. So total energy at third position is also equal to the energy in second and first position. So this concludes the topic and proves that law of conservation of energy is validated.